All right, this is problem 1. So first thing I want to do is an algebraic rewrite. So I'm not taking the integral yet. All I'm doing is rewriting square root of x as x to the 1/2. Now I can use power rule. So, and now I'm integrating. The 4 just comes for the ride. I add 1 to the exponent of 1/2. 1/2 plus 1 is 3/2, and then I divide by 3/2. And because it's a definite integral, I'm taking it between 1 and 4. Notice I no longer have the integral symbol because I have integrated. All right, I'm going to clean this up a little bit by bringing the 2/3 up. So that'll be 2/3. Okay, I said 2/3, but it's a 3/2. But when I bring it up, right, you take the reciprocal of it. That's why it's coming up as 2/3. And I'm multiplying by 4x to the 3/2. I haven't plugged in the 1 and the 4 yet, so I have to put that there. And that's going to be 8/3. So let's go ahead and put it over here. 8/3. So that's the 4 times 2 is 8. 8 over 3. X to the 3/2. Take it from 1 to 4. Okay? All right. So I'm going to leave the 8/3 on the outside while I substitute 4 into the x to the 3/2. So that's 4 to the 3/2 minus 1 to the 3/2. So 4 to the 3/2. So this is like saying square root of 4 to the 3rd power, right? Or square root of 1 to the 3rd power. So the 1/2 is the square root, the 3 is the 3rd power. And we'll work that out. So square root of 4 is 2. 2 to the 3rd is 8. And you do anything to a 1, it's 1. So that's going to be 56/3. Number 2. All right, so I'm just using regular power rule. So there's no need to do any kind of algebraic rewrite. This is a straightforward power rule problem. So that's going to be 3x, add 1 to the exponent, divide by the new exponent. What is the exponent of x? The exponent of x is 1, so it's x to the 2nd power, divide by 2. And I'm going to take it between -1 and 2. All right, let's clean that up a little more. So it's x cubed minus x squared. Take it from -1 to 2. We substitute the values. 8 minus 4. So I just substituted 2 into here. 2 to the 3rd is 8. 2 squared is 4. Minus -1 to the 3rd is -1. -1 squared is +1. This minus sign is that minus sign. So that's going to be 4 minus -2, making it 6. All right, that's example 2. Sorry, problem 2. Number 3. If I can get it up here. Number 3. All right, let's see what we got here. All right, so recognize, what is this a derivative of? Secant x tangent x is the derivative of secant x. So when I integrate it, I simply write secant x. There's no substitution, there's no simplifying, there's no rewrite. Secant x tangent x is the derivative of secant x. And I'm just going to plug in pi over 4 and pi over 3. All right, and continuing, so I'm just going to do secant of pi over 3 minus the secant of pi over 4. Now, a lot of people don't have secant of pi thirds memorized. In fact, I do not. So I rewrite it as a cosine and then use my unit circle ideas. Right? So cosine of pi over 3 is 1/2, I think. So that's 1 over 1/2. And cosine of pi over 4 is square root of 2 over 2. Okay, so when I rewrite this, 1 over 1/2 is same as 2. And 1 over square root of 2 over 2 is same as square root of 2. Okay, that's just algebra. Hopefully you can figure it out. All right. 4? Oh, okay, fine. So I'm just doing this part. Okay, I'm just doing that part. So 1 over square root of 2 over 2. So I'm just copying it right now. That's equivalent to, you flip it, so it's 2 over root 2. Multiply top and bottom by square root of 2. And I get 2 root 2 over square root of 4. Square root of 4 is 2. And when the 2's cancel, it just leaves you square root of 2. Now you might be wondering, how did I do all that? I actually didn't. Okay. Cosine of pi over 4 is just 1 over square root of 2. However, you've been taught that it's root 2 over 2. 1 over root 2 and square root of 2 over 2, they're equivalent, but you've been asked to memorize it as square root of 2 over 2. But I also know that this square root of 2 over 2 is the same as 1 over square root of 2. And when I take the reciprocal of that, I get square root of 2. Okay, so it wasn't like I actually did all that in my head. I did it from here to here. Okay, all right. Let's do this one. So what is the integral of sine? Integral of sine is negative cosine, right? Because the derivative of cosine is negative sine. So that's going to be negative cosine x. And I'm going to take it from pi over 2 to 5 pi over 4. Now, I know I am not consistent the way I said it. Like, take it from pi over 2 to pi over 4. Take it from 5 pi over 4 to pi over 2. And don't worry about it. Somebody will correct me, I suppose. Negative cosine x, I'm plugging it. But you always plug in the top number first, which I wrote it very badly. So it's negative cosine of 5 pi over 4. Don't put an x there because it's replacing the x. Minus, and it's a negative cosine, so it's plus cosine x of pi over 2. I almost did it again. So it's negative cosine of 5 pi over 4 plus cosine of pi over 2. Well, cosine of 5 pi over 4, that's more than pi, so it's in the third quadrant. That's going to be negative root 2 over 2. So it's a minus a negative, or a negative of a negative. And cosine of pi over 2 is 0. So this is just square root of 2 over 2. And that's the answer to number 4. Number 5. Okay, so this one's going to require a little bit of finagling. All right, so now I have a bunch of functions. I have 3x cubed. I have 2x to the 4th plus 1. I have this exponent of 4. So I'm looking at this. I'm thinking, oh, what is the derivative of 2x to the 4th plus 1? Well, the derivative of that is 8x cubed. So I have almost an 8x cubed here. So what I'm going to do, I'm going to take the 3 out, rewrite it like this. I'm going to put a little space in there, and I'll show you why in a second. I'm just copying everything else. I just got that 3 out of the way. It's a number, so that I can just shove it out of the integral. Now, the derivative of 2x to the 4th plus 1 is 8x cubed, right? 4 times 2 is 8. Subtract 1 from the exponent. So I am missing an 8. To compensate for that 8 I put in, I divide by 8 out here. So now I have the derivative of this part sitting right there. So that means I could just use power rule on this whole thing. So 3/8 is coming for the ride. And that's going to be 2x to the 4th plus 1. I'm doing the power rule on the 4. So I'm adding 1 to the exponent, dividing by the exponent, and taking it between 1 and 0. Let's clean it up a little bit. I like to multiply the 8 and the 5. That'll be 3/40. And I'm just going to leave it out there. Okay, I'm going to leave it out there. So if I plug in the 1, that's going to be 2 plus 1 is 3. And that's going to be 3 to the 5th. 3 to the 5th. I don't know what that is. I think it's 3 to the 5th. 243. Let's pretend that I'm right. All right. I don't know why I used parentheses there. That was stupid of me. I don't need parentheses. If I plug in 0, excuse me, that's going to be 0 plus 1. 1 to the 5th is 1, so it's minus 1. So it's going to be 340 is times 242. I can reduce that. Reduce that by a factor of what? At least 2. Let's try it. That's 3/20th. That's going to be 121. So when I work that out, that's good. And by the way, you don't have to do this by hand. You should do, I don't know why I'm doing it by hand. So it's just 363 over 20. Okay? And if you give me a decimal answer, that would be fine. All right, number 6. Let's pause the video. This is long enough. In fact, we're just going to stop it here. So these are answers for 1 through 5.